Welcome to Excellencia School of Chemistry, presenting to you the volumetric analysis of this year's WASSCE examination, and of course chemistry. And here on the screen you can see the questions. A is a 0.100 mole per dm cube HCl aqueous. B is a solution containing 5 grams of Na2CO3.X-H2O in 1 dm cube of the solution. Put A into the burette and titrate it against 20.0 cm cube or 25.0 cm cube portions of B using methyl orange indicator. Repeat the titration to obtain consistent titer values. That means concordant values, okay? Tabulate your results and calculate the average volume of A used. Below is the equation for the reaction. Now, we have also the equations below. We are going to tackle all of them. And here we have, I have already titrated it. For want of time, I present to you the already titrated value. Here, the color is orange at endpoint. Is orange, and I use the white tie so as to be able to notice the endpoints. That is to be able to note the color change at endpoints. So you can see the way the table is. Don't forget that you must write the volume of pipette used, which is the volume of base, because you have either 20 cm cube or 25 cm cube. You present your table like this. Do not forget the units in cm cube. First titration, you put the unit. Second titration, third titration, and you have the average volume of A used. Average is the value of the first titration plus second plus third divided by 3, and you have the average volume of A used as 10.45 cm cube. And now we have the second question there, which is from the results and the information provided, calculate the concentration of A in gram per dm cube. First of all, you write the formula, you express the formula. Molar concentration, N, is equal to mass concentration, small m, over molar mass, capital M. And we have to calculate the molar mass of HCl. We show the work. We don't assume, we don't import it. You show the work because it carries a mark. And HCl is 1 for hydrogen, 35.5 for chlorine, which gives you 36.5 grams per mole. That is molar mass of HCl. And having noted that, the next thing is to make subject of formula. You don't just substitute inside. You make m, small m, the subject of formula. Then you substitute, okay? So small m is equal to n multiplying capital M. And here is it. So the mass concentration of A is 3.65 gram per dm cube. And we have the next question there, which says the concentration of B in mole per dm cube. Yes, we use the formula CAVA over CBVB equal to NA over NB. We make CB the subject of formula, but we must know what the parameters stand for, right? Ca is the concentration of the acid in mole per dm cube, don't forget that. And Cb, concentration of B in mole per dm cube. Va is the volume of acid, which is the average volume of A used, 10.45 cm cube. And Vb is the volume of base, which is the volume of pipette, which is 25 cm cube. And making Cb the subject of formula, we have the expression here on the screen, and we substitute. We have it as presented here. So concentration of B is 0.0209 mole per dm cube. And we have the next question here. Calculate the molar mass of Na2CO3.X-H2O. And here is it. We still use the formula, okay? We write the formula as you can see on the screen. We've used this formula earlier, but this time around, you make capital M the subject of formula. Capital M is equal to small m over n. And you substitute the values. Small m is the mass concentration given us in the question. You substitute the values. You find the molar mass to be 239.23 gram per mole. Now the next question now is calculate the value of X in Na2CO3.X H2O. Now we break it up, okay? We have 2 Na here, so 2 Na plus C plus 3O plus X H2O, okay? 2H plus 1O equal to, you equate it to the molar mass, okay? You equate it to the value of this molar mass, which is 239.23. You now substitute for each of these, okay? Sodium is 23, carbon is 12, oxygen is 16, plus X 18 for water, yes, 18 for water, 2H plus 16, equal to the relative molecular mass. When you calculate this one, to give you 106 plus X H2O, and H2O is 18, right? So X 18. Now you have to make X 18 the subject of the formula. You make X 18 the subject of the formula by bringing 106 over, becomes subtraction, right? Making X the subject of the formula becomes 113.23 over 18, which gives you 7. Please present your work in the nearest whole number. The next one is value of V. Okay, sorry. The next one is volume of B. Yes, the question says calculate the volume of B that will be liberated from the, sorry, I take it again. Calculate the volume of carbon dioxide that will be liberated from the volume of B used in the titration at STP. STP is standard temperature and pressure. And before I go through that, I want you to take note of something, that our concentrations here are all expressed in 3 significant figures. Do not forget that. Express your concentration in 3 significant figures. And you note that our values here are concordant, okay? It means that the difference between the highest value, which is 10.50, and the lowest value, which is 10.40, is not more than 0.2. Here it is 0.1. It can be up to 0.2. It can be less, but please not more than. And you note that here our works here in this table are presented in 2 decimal places, and the second decimal place is either 5 or 0. Do not forget that. Do not forget to also use the correct units. And back to the question, the last question, volume of CO2 from the volume of B used. Okay, the volume of B is 25 cm cube, and we convert it to dm cube. It will give, by dividing with 1000, it gives us 0.025 dm cube. Okay, we now find the amount of B in 0.025 dm cube, which gives us concentration times volume, that is 0.0209, that is concentration of B in mole per dm cube, multiplying the volume is 0.025, it gives you 5.23 exponential minus 4 moles. That is the amount of B there. And from the balanced chemical equation, here, we see that the ratio 1 mole of Na2CO3, 1 mole of the B gives us 1 mole of carbon dioxide, which is 22.4 dm cube, okay, at STP, molar gas volume at STP. So bringing it down here, we see that we make a simple statement, okay. 1 mole of B gives us 1 mole of carbon dioxide, 22.4 dm cube. Therefore, 5.23 exponential minus 4 moles of B would give us X. Making X the subject of formula, we find that the volume of carbon dioxide from the B used is 0.0117 dm cube. Thank you very much.